This is my Lab 2 presentation. The main purpose of the lab was to model the excess charge on a charged piece of tape using GlowScript. The main models and principles used were Newton's third law, Coulomb's law, and the force of gravity. And the results were that the magnitude of the electric force on the tape is 2.82 times 10 to the negative 4 newtons. The magnitude of the gravitational force on the tape is 2.45 times 10 to the negative 3 newtons, and the GlowScript model provided different results than the previous lab's results. The data that was needed to complete the GlowScript code was the mass of the tape, which was 0.00025 kilograms, the separation distance between the tapes, which was 0.012 meters, and the charge on the tape, which was 6.26 times 10 to the negative 9 coulombs. The main physics idea in this lab was Coulomb's law and how similarly charged objects interact with each other. The system and surroundings for this experiment were the two charged pieces of tape. Some potential errors in this lab was that the data was modeled with too few electrons and that the values were calculated incorrectly. Some assumptions made were that the pieces of tape were equally charged, the pieces of tape had an even amount of charge over their surface, and there was no air resistance. This is the main GlowScript model. The white arrow represents the net electric force vector on the top piece of tape. The green arrows represent the electric force vectors on the top piece of tape, and the yellow arrow represents the net gravitational force vector. One of the additional questions for this lab was, what if you had modeled each of your tapes as a single point charge, like in the previous lab? So the net electric force value when modeled as a single point charge is 2.45 times 10 to the negative 3 newtons, and this value is much larger than the net force value of 2.82 times 10 to the negative 4 newtons when modeled as multiple charges on a line. The question was, why do these estimates differ? Which value is more likely to be closer to the real value and why? So these estimates differ because each electric force vector does not point only in the vertical direction. This means that there are horizontal components of each of the electric force vectors on each part of the tape because of the interaction between each charge. And the value obtained when modeling the tape as having charge across the tape is more likely to be closer to the real value, because the tape used during the experiment would not have had all of its excess charge located in the center.